Hello. So I've added some the beginnings of audio, or my first audio to the game, and it's been quite fun doing this. So I've just been setting the natural environment higher in the mix. So this is the first time I've used the new audio mixer from Unity, and I really like it. Um, I'll not go into it in detail because obviously Unity and other things explain how it works, but in quick summary for myself when I'm reviewing these videos in the future, the audio mixer is a singleton. Um, I think that's technically correct that it's a singleton. So it's not attached to a game object. It just has to sit somewhere in the assets, and I've put mine in my assets audio folder, and it looks like this. And you can expand it to look at all the individual pieces of it, which you can see in this view if you open the audio mixer panel. So you can click on the the uh, the the other sort of hierarchy view is the groups. So each the master audio is split. You split it into groups, and I've added the following top level categories. I've said localized sound. That's where I plan to have audio sources that are geographically or positionally related. So a bird flying across the sky makes a squeak or a chirp. That would be localized to where the bird is in the scene, positional. And then non-localized. So maybe I should have called it positional, non-positional. Non-localized might be just like game music that's playing in the background, or menu noises or menu music or some sort of ambience. That's all I've got at the moment. So I've put these here as like provisional placeholders because I'm not actually got any music or ambience playing, but you can see my intention. For localized, I have started to use it. So I've split that up into dialogue. The reason for splitting it into groups like this is it means you can amplify or attenuate the a particular group of sounds rather than having to go through doing them individually one by one. So through code or manually, like here at the beginning, you can set up your the particular mix you want for the different things. So dialogue, I want to be quite high in the mix, and this is a new term to me. Foley, I believe it's pronounced, relates to sort of sound effects that you would add into a movie or a video game. Things like footsteps and a cup being put down on a table and all those things that you'd add in. Often just sampled sounds that you add in. So I've got one in there called footsteps, which is separate, but everything else for now I've just lumped in together as Foley, so that that's things like birds and insects, leaves rustling, wave wash. Actually, not wave wash. So, in fact, none of those things. So they're all in the environment. So take that back. Footsteps is a separate subcategory, but the things I've added into Foley are to do with at the moment to do with the like noises, the helmet. I've made it so you can raise and lower the visor, raise and lower the microphone boom, and the jaw dash. Is there anything else? I think that's it. Yeah. So those things I've just added into Foley for now. Maybe I'll break them out in due course, but it's easy enough to rearrange all that. And then I've got, so that's my kind of sound effects or Foley, and then natural environment. I've currently thinking in terms of breaking up in weather, leaves rustling, birds and insects, and then wave wash of water and lakes when you get close to the edge of the water. So must be 1,000 ways of cutting and dicing this. This is just what I've gone for. So if you want to change any of the parameters of this master mixer, you click on something like this one to bring it up in the inspector, and then you can add effects that will then be listed here and mess about with the values and so on. So if I wanted to be able to change the resonance of this low pass filter in real time from code, you right click on it and you click this expose resonance option at the top, and it will then put that and you'll be able to, it will expose it, and it will list it then under here. So at the moment I've only got one item that I'm controlling from code, and it's the cutoff frequency for the low pass filter on the master controller. So this is the master controller low pass here. So you can click on it and unexpose it, but currently I'm using that, so it's listed here. And you can change its name from this horrible long thing. So this is the actual name I've called it. I've just called it low pass filter, and then I can adjust that in code. So let's just hit play. There's too much rabbit. So hit play. I've just come away from the edge of the river or lake, whatever it is, because it's very noisy there. So you can hear the wind that is blowing, and the wind is reacting in the same way that the grass and the trees are. So if we look at this grass blade ahead of us, you can see it moves when the wind blows, and you can hear the wind pitch and volume increasing as the wind increases, and it falls silent when the grass blade stands up vertical. So I'm quite pleased that's working all right. It's using the same sample texture map. So I've organized things into these manager objects. So I've got a wind manager empty object that just has a script attached, and it has the audio source for my wind here, wind atmosphere calm, which I've obtained from the internet, and then I'm using Audacity to trim and spruce up and cut out the bits that I want to use into my clips. And then I've said the output for the wind noise should be directed to this mixer group called weather. So that is this one, and you can see the equalizer rising and falling with the wind clip, and you can see its volume here is responding in real time, as is the pitch. The volume is more sensitive the way I have it, and the pitch less sensitive. So that's rising and falling, and it's doing that because the script I've written here, called Wind Manager, is sampling the same texture map that the grass and trees sample in their shaders, in their shader graph, to work out the movement of how much they're going to bend in the wind. So they sample the texture and read out the RGB values for strength of wind, direction of the wind, and turbulence, and then I'm using those to directly increase the volume and pitch, and so it all works in concert, and it's pretty cool. I'm very pleased with it. So that is So I'll just nip into the code for that. So Wind Manager. So we've got our texture 2D, and then what I had to do was mimic the same algorithm that I'd created in the shader graph, so that I could get exactly the same sample from the texture map at the same location in the scene, and instead of applying it to a blade of grass, apply it to the audio clip. So in the awake we get a link to our Cosmos Manager and to our player and to our sound clip, audio clip or audio source, and get a few other references, cloud materials and stuff. So the Wind Manager, as well as doing the audio for the wind, is also doing other things affected by wind, like moving the clouds. So that's why, and doing the fog, which are all affected by the wind. So if we want to speed up the wind or make it a particularly calm day in the game or make it a stormy day, just changing one or two settings like the wind strength here in this Wind Manager class means that all the clouds, the sound and everything all respond from that simple change. So I'm using fixed update rather than update because these kind of physical things, I reckon they don't have to be updated all that quickly. Most of Unity's physics engine itself uses fixed update, which is something like 50 times a second rather than potentially 300 or whatever your FPS is. So fixed update seems to be ample for anything physically like clouds and fog and wind noise, in my opinion, so far. So update wind noise is very simple. It simply samples the wind map and gets back the color at that pixel based on where the player is standing, and it then says, well, set the pitch to the redness of the pixel, and set the volume to the redness of the pixel, because the red color of the pixel, the redness, represents the wind strength. G represents the direction and B represents turbulence. So we're only using the wind strength, so the main wind strength, and then we have a multiplier, which is just generally applied by the Wind Manager to everything, so that we can use the texture and scale it up and down for a calm day or a stormy day. But the rise and fall of the wind will be dictated by the same texture. So I suppose all the magic is happening in this sample, the wind map method, and there's not a lot to it. We just take a position which I've called UV, which will be our pixel position eventually. But so UV starts off as being our player position in the scene, and then the only thing is, if we were sampling the player's position, they're standing still, they're not moving. We don't want to be getting the same strength of wind just forever, just when we stand there, because in real life the wind, if we stand in one place, the wind will fluctuate even though we're standing in one place. So we take our position as a sort of a seed point in the map, but then we use time. As time progresses, then we simply move our position, having started our seed, our starting point in the map. We just progress through the map by the amount of time that has elapsed in the game, and again we apply a scaling factor just for empirically to get something that works well for the texture map. And that's the same thing that's kind of going on in the shader graph, so it's pretty simple. So that UV position gives us which pixel we're going to sample. and then we go ahead and sample it. So our integer x for the sample position will be a rounding up of the float value here of the size of the wind map texture, or the width of the wind map texture, and the same for the vertical for the pixel. And then we get the pixel color, and that's it. So very simple. Oops, didn't mean to press that. So there we are, that's the wind noise. And then having done that, I was really pleased how it made it feel like the game was coming to life with having the sound. So I added the audio for the water. And as you can see, it's pretty loud in the mix here. I'm just going to turn it down a touch. So turn it down a bit. Turn the wind down as well a bit. So when I go underwater here, you'll hopefully notice a change in the sound, and that is done by applying a low pass filter, so that effectively it muffles all the high pitched noises, which is kind of what happens when you go underwater. So I'll turn it back up and then demonstrate that. So I think weather was up quite high. I just clicked out of that. So that demo there totally failed to show the low pass filter because the water's slightly too shallow to cover my player's head entirely. Because I've set it to kick in the low pass filter when the player is beneath the water level by a certain value. I think it was like 1.8 maybe, the height of my player. And it seems that I'm just missing that threshold. Now, the water level actually rises with the pull of the moon, so it might be, I'm just going to let it play on a little bit, so that the moon is higher in the sky. That will pull, the gravity of the moon will pull the water level up slightly, and then it might be just right for demonstrating it. So I'll give that a go. And then I've moved it on. No, that did not succeed, and it's super loud in my ear. Don't know how loud it's coming in the recording. So let me go and change the threshold for the height of the player where that kicks in. So in my water manager, Update the tide, update fog, update water noise. So player head level is the feet position plus 1.2. Let's just knock that down a bit. So let's just say that that's like 0.8. And I'll come back and sort this out a bit better. So let that recompile. Either that or I've missed something and I've upset something in the last time I was working in the project that's gone wrong. I don't think I've been doing anything that would affect it. There we go. So you can hear the muffly sound, and if I jump, you can hear the change. So, out of the water and under the water, or much more muffly. So I can play around with the I can play around with the levels of this, but the point is you can hear it kick in. Out of the water and then underwater, and it's killed the high pitch bobbling of the water. We jump out, we can hear it. So got there in the end. So that is the water. I'm going to walk away from it because it's really noisy. So I probably want to turn down the water in the overall mix. It seems crazy loud. So why is the sound of the water diminishing as I walk away? The way that's working is just with height of the player. Because water in my landscape everywhere is at the same level, it's just one massive plane that intersects the landscape, that goes up and down with the moon orbit. Then that means that I've just simply been able to make use of that and say, well, in that case I'll just use the elevation of my player, and as the player gets closer in elevation to the water level, then that will do as a proxy for how close to the water's edge they are. Now it doesn't, there are edge cases, so if I'm on a flat plateau that is really flat, a bit like what we can see in this scene, we can still hear the water even though we're a long way from it. So it's not perfect, and it could definitely be improved. But if, for example, if I went the other side of the water where it rises steeply into a mountain, then the elevation is increasing quite rapidly, and so the drop off in terms of the volume of the noise of the water drops off much quicker as well because of that. So I'm going to come over here, and then what I wanted to show was the other things that I've added in. So the visor. So if I press the visor button, down it comes. It makes a funky open and close sound, and then the microphone boom can go up and down. So make some groovy noises for that, and the jaw dash can come out. And the plan for the jaw dash here is that we'll have some simple things on it, like a compass and a couple of minimal sort of user interface visual information about the environment. I want it to be very minimal, so it's sort of to partly as a sort of a homage to the original Mercenary game, because in the original Mercenary game on the Atari, your compass and your kind of computer dashboard was in that sort of this lower quadrant of the screen, so it's kind of a homage to that, really. I deliberately don't want like heads-up displays covering the view of the landscape. I want it to be very much like a human experience as we walk around the world. But anyway, I was having fun adding in noises, and I'm quite pleased with these noises. That maybe is inappropriate, but it's kind of fun. Quite like it. You can probably tell that I nicked that from the opening and closing of a car window. So I've added them in. The other thing then is, if the mic is down like this, I can record audio in real time if I press a tab key. So I've added a control. So I press tab key now and I'll speak into it. I'll just go over to these characters over here, because the intention in the game is that you will interact with these characters by talking to them rather than clicking or doing things. And to do that, I plan to capture the audio that I speak into the microphone, and then use a speech-to-text protocol to convert it to text, which then the game will make sense of using the power of magic. So here we are. Here we've got some characters. I want to speak to them, so I press the tab key. Hey guys, you look like you're having a fun day. Is that right?
Hey guys, you look like you're having a fun day. Is that right?
So you can see that it sort of there was a little bit of processing on the voice, and it's really just at the moment that just simply demonstrates that it's doable, that I can record the audio from the microphone, and that's as good as I need for now. And nothing beyond that is going on. But it's kind of exciting that I've started the journey, the baby steps of beginning to get onto that journey of recording the audio that is how the interaction of the game is going to be based on. And the next step is then to to process that, to turn it into text in a performant way that I'm hoping can be done. Maybe using like a Google speech-to-text API, or maybe something based on the machine itself, and then send that to like ChatGPT or something for the characters to be able to reply to the text that they have received. So ChatGPT will turn back text as a that will be whatever they're saying in response, and then I intend to do the reverse, so a text-to-speech protocol that will turn the ChatGPT response back to speech so that they speak back, which I'm super excited about. I don't know whether this is going to work, but I think in theory it should. It's just really the performance that I'm not sure how laggy or not it will be, but I'm really excited to baby steps towards that journey. I'm so excited.
I'm so excited.
So I'll stop here and go and have a cup of tea to celebrate. So I think that will do for the end of the video. Stop.